All right, problem set 3, the mole. Here we go. Number 1, to define the mole, just make it simple. Don't go into all this elaborate detail. Just basically a mole is equal to Avogadro's number, which is 6.02 times 10 to the 23rd. If you left it at that, you're in great shape. 1 mole is equal to 6.02 times 10 to the 23rd. Yes.
Why would you do that?
Because I was gone.
By the way, if you ever need extra copies, they're online. They're on campus. They're there. Okay. All right, number 2 or 2B, or sorry, 1B. Really, the answer there is the reason why we're not going to use a dozen is because it would make our quantities huge numbers, right? Just giant numbers, ridiculous giant numbers. So the mole is the best way to go as far as not only because it puts things a little bit better in perspective on the amounts, but in the long run, it's actually easier to use. All right, let's see, number 2A, I calculated 1.3 times 10 to the 9th. 1.3 times 10 to the 9th squared kilometers. If you did not get that answer, it's most likely because you did not square your, some of you are like, oh yeah. Okay, you probably did not square your conversion factors. Is it cubed? Oh, it is cubed. Sorry, it is cubed. My fault. I can't even read my own writing. Yes, thank you, cubed. So you probably did not cubed your conversion factors if you got that wrong. So make sure you do that. All right, and B is the great state of Texas. No, not a great state. Not a great state. All right. State of Texas is the answer, at least, whether it's a great state or not. All right. 3. You don't like Texas, huh? What's wrong with Texas? Oh, it's Texas. Nothing good ever comes out of Texas. Country music. Well, that's more like Tennessee, right? Nashville. All right. Here we go. 3. I'm just going to run down from A to D. So 152.16 grams per milliliter. Again, 152.16 grams per milliliter. No, per mole. Why am I saying milliliter? Per mole. Jeez, it has got to be done with today, right? Okay, B, 164.22 grams per mole. C is 148.22 grams per mole. And D is 132.17 grams per mole. Do I need to repeat any of those? Or are we good? C, 148.22 grams per mole. Okay, make sure you can get these. 4, A, 342.34 grams per mole. B should be 183.20 grams per mole. And again, you might be one decimal, or the last decimal point might be off a little bit. Again, depending on the periodic table you're using. C should be 294.34 grams per mole. And D is 180.18 grams per mole. How are we doing? Terrific. All right, so that's 4. 5. So 5, there's a lot of numbers here. You have to go A through D. I'm just going to do A through D again. So all of these should have a 0.00 before the number, okay? Or if you put it in scientific notations, it would be to the negative third power, right? So I have 0 for A, 0.0044 moles. B, 0.0082 moles. 5, 0.005 moles. And the last one, 0.0083 moles. All right. If we're good with that, we'll move on to 6. Okay, 6A is NO. B is CO2, and C is O2. Okay, just so you have that. 7, I calculated it to be 25.4. Oh, yes. 6B was O2. Oh, no, B, CO2. 6B, CO2. All right, so 7, 25.4 grams. 25.4 grams. 8, 163 liters. See a lot of nodding. Yep. An agreement. I like it. 8, 163 liters. 9, what do I get for 9? 3.51 times 10 to the 21st molecules. 3.51 times 10 to the 21st molecules of water. And D, or 10, is 196 grams of carbon dioxide. 196 grams. Yes, sir. Number 2. Which one?
Jackson Hole. Oh, I guess 2A, because I got 2A wrong, so I got 2 wrong.
Well, if you had 1 mole of M&Ms, so how many M&Ms would that be? A mole of M&Ms, M&Ms, okay, is equal to what? 6.02 times 10 to the 23rd M&Ms, okay? Okay, so you have a box, okay? So if you have a mole of M&Ms, how big would the box need to be to hold all of them? Okay? Assume that the volume of a single M&M candy is about 2.2 cubic centimeters, right? So 1 M&M is equal to 2.2 cubic centimeters, okay? How many do you have of them? Mole, okay? So in this box, you have to fit, here's my box, you have to fit 1 mole of M&Ms, okay? Which is 6.02 times 10 to the 23rd, right? So can you convert essentially, well, you know that 1 M&M has that cubic centimeters, right? So I know I have basically this. I have 6.02 times 10 to the 23rd M&Ms, okay? And we know that 1 M&M is 2.2 cubic centimeters, right? Agreed?
Yeah.
See that? Okay. Now, but we want the dimensions of what? In what? Because this would give us the dimensions of the box in cubic centimeters, right? We want the dimensions of the box in what? kilometers. Okay, so there's a few things we know. We know probably that there's 100 centimeters in 1 meter. Okay, except the fact that these are cubic centimeters, so I have to cube both these terms. And I also know that there is essentially 1,000 meters in 1 kilometer. But again, these have to be cubes. I got to cube those. And that's the math. So my number of M&Ms council, my cubic centimeters, my cubic meters, giving this cubic kilometers.
I see it, right?
Okay. What did you do wrong?
So with the, I'm gonna say the calculated as 2.3 used by the mold, I actually did 2.3 times 23rd, not.
Oh, yeah.
And then,
got it. But you got it now. Okay. 6. Okay, so 6 says, suppose pairs of balloons are filled with 10 grams, right, of the following pair of gas. So you got 10 grams of an A, right, 10 grams total of carbon dioxide and NO, right? Which balloon in each pair has the greatest number of molecules, okay, or atoms in the case of argon, okay? So how are we going to tackle this? All right, how are we going to tackle this? Okay, suppose the pair balloons are filled with 10 grams, okay, of each of the following pairs of gases. Which balloon, okay, in each pair has the greatest number of molecules? Okay, so what do we have to do? What do you think? How did you start approaching it? Okay.
I was trying to count the
Well, if you think about this, okay, so if you look at the fact that carbon dioxide has 3 atoms compared to NO, which has 2 atoms, right? That could be kind of a clue possibility. But let's see if we can do this. All right, so we have a balloon. Okay. And we have CO2 gas, 10 grams of it, right, 10.0. We have a balloon. We have 10 grams of NO, right? Make sense? So we want to know which balloon, which of these 2 balloons has the most particles in it. So I can take and figure out that I have 10 grams of CO2. Convert this into moles. All right. So the molar mass of CO2 is roughly about 44.01 grams. Okay, to 1 mole. All right. So if I get out my calculator. And I go 10 divided by 44.01. That gives me 0.2 0.27 moles, essentially. 3 significant figures of CO2, okay? So moles are like particles, right? It may not tell you the exact number of particles, but you basically know that 1 mole is equal to 6.02 times 10 to the 23rd. So you can use moles kind of that, if you're comparing mole to mole, you can kind of see how many particles you have. So NO, you have also 10 grams of NO. Now the molar mass of NO is approximately, let's see, 16 plus what, 14, I don't know, 0.1, 1 mole of this of NO. Okay, so 10.0 divided by 30, round 1, is 0.333 moles of NO. Okay, so which one has the most particles? That. Which one has the most particles? Which one of these? NO. This has the most particles. Okay. It's got 0.3 versus 0.2 moles essentially. And that's all you have to do with those. All right. Any other questions? Sure? Okay, almost out of time. All right, if there's no other questions, then let's move on to our next deal here.